This video will be about points, lines, and planes. In geometry, you need a way to talk about all the different shapes and figures you're going to be working with. So the first most basic shape is a point. And to name it, we use one letter, usually capitalized. So that would be called point A. Now you can take a point and make it into some sort of line. A line is made up of a whole bunch of points. Usually they label 2 points, so this specifically would be point A. This would specifically be point B. And we can actually talk about a couple different pieces on this line. If I just want the piece between A and B, that is called a segment. And you use both letters A and B, but above it you draw a line segment to show we started at the letter A, ended at the letter B. We could take the entire line, which we call a line, and still we'd write it as AB, so it looks almost the same as a segment, except we include arrows on both ends to show, hey, this is going forever. And then the last thing we can talk about on this line is called a ray. We still use the letters A and B. This time, though, we must start with the letter where the ray starts. So the ray started at A and went on. If I wanted to do, this actually has a second ray, we could start at B and go this way. If I said BA, that would be indicating a different ray than ray AB. We say ray because it's, like sunshine, a ray of sunshine. If you were to draw a sun, it goes out from a center point. So we can take a line, and if we put a whole bunch of points on it, there's a whole bunch of things we could name. So if I were to take this line and ask you how many line segments are on this line, well, it's easy to see the line segments between the points. We have A to B, B to C, C to D, D to E. So that would include 4 so far. But you can also start at A and end at C. There's a 5th one. You could also start at B and end at D. There's a 6th one. I'm going to keep a tally mark, 3, 4, 5, 6, so I don't lose track. We could start at C and end at E. There's another one. We've already done D to E, so we don't count it again. Or I could start at A and I could go all the way to D. There's another one. We could start at B, go all the way to E. There's another one. And I could start at A and go all the way to E. So we have, counting, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different line segments. Just looking at this one picture. You could also name different rays. Let's draw a different picture to do different rays. So we still need 2 points, but we pick a starting point and then go through all the rest. So ray WX would actually be the same as ray WY. The starting point matters, the ending point doesn't. So we'd have ray WX, or I could start at X itself, so ray XY. Or I could go in the other direction. I could start at Y and go to the left, so ray YW. Or I could have named that ray YX. That would also work. Or I could start at X and go to the left, and that would be ray XW. So even though these two have the same letters, because they're in a different order, then they're different when it's a ray. If it was a line segment, it doesn't matter what order we put it in. The last thing we can do with rays is we can have something called opposite rays. Rays that are opposite start at the same point. We'd have another ray that also starts at point B, but it goes in the opposite direction. So BA. So these are opposite rays. Some other vocabulary that will be helpful is collinear. Collinear means on the same line. A, B, and C are collinear because they are all on that same line. If I took a point and put point D out here, D is not collinear to A, B, and C. We could also talk about coplanar, but first we need to know what a plane is. A plane is a flat surface. Doesn't have to be square-shaped. It's infinitely long, but we can't draw it. If we could keep these sides extending out, that would be a plane. In real life, a tabletop would count as a plane, or a floor, or a ceiling. All of those would count as planes. So a plane, if we had something that's coplanar, that means they're both in the same plane. Coplanar, two lines in the same plane. And it really doesn't have to be lines. It could be any object. 2 points in the same plane. 2 rays in the same plane. Plane. Also, in a plane, if we had 2 lines, we could find parallel lines. Parallel lines are lines that never cross. If I put this green one in, green is definitely not parallel because it's crossing those 2 blue lines. But the 2 blue lines would be parallel because they are lines that never cross. Half of geometry is learning these new terms. There's a lot of vocabulary you have to know. So then the last thing with a plane is skew lines. For that, we're going to need to draw a 3-dimensional object. Say we have a cube. So when we draw a 3-dimensional object, each corner is a point. So we'd say point A, B, C, D, E, F, and G. It's 3-dimensional, so there's a part we can't see, so we have to draw dashed lines to say this is actually behind. So we have one more point, A, B, C, D, E, F, G, H. So this cube is made up of a whole bunch of planes. One side of the cube would be a plane. The front side would be a different plane. And the planes can cross as well. When they cross, when they meet each other, they form a line, like line ED. But we can also look at the sides themselves and look for parallel lines or skew lines. So we said parallel lines are lines that will never cross. So DC, and they have to be going in the same direction. See how both of these start kind of low and then go up and to the right. Start kind of low, go up and to the right. We could also say AF. That is another line segment that is parallel, or GH. So AF is parallel, and the symbol for that I should draw in. Parallel to EB, is parallel to CD, is parallel to GH. Well, we also have something called skew. Lines that are skew lines will also not cross, but they're not going to be going in the same direction. So I'm going to use a different color and say we're looking at line ED. Now the parallel lines would be all the other lines going up, but we want a line that is skew. Skew lines will not cross each other, and this is not a mathematical definition, it's just the idea of a skew line. They won't cross, but they are not going in the same direction. So that means all the lines going straight up and down, those are out of the running. But a line like HC will never cross ED. They're never going to touch. But they are not parallel because they're not going in the same direction. So ED is skewed to HC, or I could say ED is skewed to AB. Those will never cross, but they're not going in the same direction. I could not say EF though. Let me use a different color to show. This one is not skew to ED because they touch each other, they cross each other. Looking at this picture, we could also say HG is skewed to ED. It will never touch line ED, but it's not going in the same direction. And AF is another line that's not parallel and not touching. So those are the things we need to know for points, lines, and planes.